Hello, welcome students. So as you know, uh, today we will begin with a new chapter that is about waves. Okay, so waves you have studied so many things on waves in school classes, and here also what we are aiming is we will make some qualitative study of waves first. That means that in its physical features. Then we will try to analyze it mathematically, and subsequently we will go into some of the phenomena exhibited by waves in different situations, and that such phenomena will be analyzed, studied and examined in detail, both physically and mathematically. Okay, so that way the mathematical analysis will give you some better understanding of the phenomena from physics point of view. Okay, that is our primary aim. Here, essentially, we will be dealing with two kinds of waves. One is called a transverse wave, other one is called a longitudinal wave. Okay, we will discuss in detail about both kind of wave, but we will start with some introduction. Okay, so our syllabus, as you know, we have taken the AP French, Vibrations and Waves, written by AP French, as the reference book or book for study, and these are the topics to be dealt with in this chapter. And I would assure you that over the top, each and every topics are of highly interesting, and a lot of information which related with the day-to-day life will get from these topics. Okay, uh, and we will try to make it as interesting as possible with a lot of graphics, animations, gifs, and mathematical interpretations. Okay, and by showing you so many life related applications. This way, we can make the entire session highly interesting and attractive. Okay, so anyway, as you know, what is a wave? We have a notion about waves. Okay? In our day-to-day scenario, we come across with so many waves. The most interesting one is that of water waves. Okay, that you come across in lakes and rivers and oceans. Okay, essentially, you cannot imagine a life without waves on Earth. So many types of waves you come across, whether you realize it or not, it doesn't matter. You have to, for listening, you need sound. Okay, sound is a kind of wave. For light, you need wave, light waves. The light that we get from the sun is coming in the form of light wave. And there are so many other examples for wave. The signals that you get in your telephone or mobile phone or the television or radio, all are operating on the basis of wave energy that you get. Okay, so wave is fundamental, and we cannot imagine a life is impossible without without waves on Earth. Okay, that's the very importance of significance of waves, or the study of wave is so important because of these factors. So we say that it is a method to propagate energy from one point to another. Wave is essentially a way, a means to send energy from one point to another point. Okay, usually we can have so many examples to transfer energy. For example, when you are throwing a stone, the stone carry energy, so energy is transferred from one place to another. Suppose a gun is fired, so what happens? Bullets carry energy with it, and it reaches the target, and it penetrates. So penetration, for the penetration, it make use of the energy. Energy is consumed for penetration. Similarly, running water. Okay, hydroelectric jets, where running water is made using running or driving a propeller or a turbine, and it converts the mechanical energy into electrical energy. That's another example. Okay, similarly, ocean waves, carry immense amount of energy that can be made using so many applications, and that is exactly an example, a real example for waves. Okay, and we can conclusively say that waves are a means or a method to propagate energy from one place to another without the actual motion of matter from one place to another. The last line is very important. Whenever wave is running or energy is running, propagating from one place to another place, the medium itself is not propagating. Medium is still there. Medium is simply making some to and fro motion, okay, up and down motion, but energy gets forwarded. Okay, so that is very important. Medium itself do not undergo any shift, any displacement from its position, but the energy gets transferred from one place to another place. It's a very interesting thing to note down. Okay, and in wave motion, uh, basically is a disturbance. You can say that wave motion is disturbance, and this disturbance enable us to transfer energy. Okay, so in this disturbance there is some speciality. That disturbance is a type of periodic vibration. Periodic vibration, who is vibrating? The particles of the medium vibrates. Okay, so the vibration of the particles of the medium enable or facilitate transfer of energy from one place to another place. Okay, and this vibration is essentially a type of simple harmonic vibration. Okay, to and from motion, to and from motion, and this motion is handed over. This motion carry energy, and that energy is handed over from one particle to other particle without the actual displacement of the matter from its mean position. Okay, that is obviously, it is clear. Okay, so energy get transferred, but the particle does not make any displacement, or simply make an oscillation from its mean position. That's very important. That can be experienced. Suppose you have a lake, suppose you make some ripples over the lake and you put some leaves over it, some floating things, then you can see that the floating thing simply moves up and down from its position. It does not get displaced virtually. Okay, understand? But the energy get transferred. The disturbance will be spread out on the entire surface of the water. But the leaves, whatever floating things you have placed over the water, that will simply make an up and down motion. That itself is a proof for the fact that particles of the medium does not undergo displacement. Okay, very clear cut example. And there are two kind of motion possible for particles in a medium. Okay, either the particles of the medium can move up and down, whereas the energy will move forward. Particles move up and down and energy move forward. Such kind of waves are actually known as transverse waves. Okay, transverse waves. I hope the idea is clear. We have shown here a graphic in which it is shown how the energy propagates and how the particles move. Particles are moving up and down. And the second kind of motion is what is called a longitudinal wave. In a longitudinal wave, we can see that particles of the medium moves to and fro, forward and backward, but energy is continuously, perpetually moving forward. Energy is perpetually moving forward, whereas particle, you can see the spring here. Spring undergo oscillatory motion from its own position. Spring itself is not getting displaced. If you closely watch it, you can see that spring itself is not getting fully displaced. From its own, every ring of the spring simply execute a to and from motion, backward, back and forth motion. But that enables to transfer the energy. Whereas in the transfer motion, you can see every ring is executing an up and down motion, but the energy get transferred. So the first one we call transverse wave, and the second one we call longitudinal wave, because of the difference in the motion of the particles. Because transverse means perpendicular. Okay, so particles are moving perpendicular to the direction of propagation of energy. Whereas for the second case, longitudinal means something which is along the direction of energy propagation, parallel to the direction of. So we call it longitudinal wave. So this way, the entire wave propagation we can broadly classify into transverse waves and longitudinal waves. And it is clearly shown here that every constant particles are simply moving up and down in case of a transverse wave, up and down. Okay, you can show the red spots in the wave. If you closely watch it, you can see that red spots are simply moving up and down. They are not executing any horizontal displacement. Okay, and another thing is that how the energy propagation is made possible. Here you can see up and down motion creates some raised projections. These raised projections are called thrusts. Okay, and the lowest portion where the displacement is lowest, that is called the trough. So essentially any wave is a collection of alternative trough and crust. Okay, so thrust is something having highest or the maximum displacement, and trough is something having the lowest displacement. You can see the valley point. So here the peak point and valley point. So and the distance between any two peaks or the thrust, the distance between any two thrusts is what is called wavelength. Okay, distance between two consecutive or adjacent thrust is called wavelength. Similarly, you can also say that distance between any two adjacent trough is also wavelength. Okay, that is usually indicated in lambda. Okay, so that is a very important idea. So three things we studied. One is that particles are simply moving up and down or to and fro. Secondly, they produce crust and trough. Okay, crust and trough, they are alternate, and the distance between two troughs or two crusts is equal, and that is called wavelength. These are things which we observe from this animation. And another broad classification of waves is called elastic waves and inelastic waves, because elastic property of wave medium is very important in propagation of waves. I think you know what is elasticity. Elasticity simply means whenever you apply some force on a body, any matter, it may undergo its shape change. It may undergo its shape change. Suppose you withdraw the applied force, what will happen? That body or the matter may regain its original shape and size. For example, some rubber block, you apply a force, what happens? Rubber block's shape may get changed, it may deformed. The moment you withdraw the applied force, what happens? It will regain its original shape. So that property is called elastic property. So if a material is highly elastic, its ability to transfer wave will be high. Okay, so waves which require elastic property of waves, elastic property of materials are called elastic waves. Once again, any wave which require or which make use the elastic property of material is called elastic waves. And any wave which does not need the elastic property of the medium, that is called inelastic waves. That is called inelastic waves. Okay. So let us see some more details. For propagation of waves, the constituent particles of the medium must vibrate elastically with respect to a mean motion. So that is the condition for the propagation of an elastic wave. Okay. So for this case, what need the elastic property of the medium is very important. For example, you take the case of a wave traveling along a spring. We have already shown you the example. In that case, elasticity of the spring is taken into account. If there is no elasticity, what will happen? When you compress the spring will get compressed, and when you withdraw the applied force, spring will not regain its original shape. Understand? So, but you know that whenever a spring is compressed and the moment you withdraw the applied force, the spring automatically regains its original shape and size. So we can say that wave is propagating along a spring because of its elastic nature. Similarly, many other solid materials, maybe steel, maybe aluminum, copper, whatever, they all have very high elastic property, and they are very good conductors of elastic waves. For that matter, air is also a very good elastic material. Through air, you know that sound is propagating because of the elastic property. And similarly, many liquids also have elastic property. So they also transfer energy, they also transfer wave. For example, water wave is propagating along the surface of the water because of the elastic property of the water. Okay, so we can say that the propagation of the energy takes place due to the elastic property of the medium. So many examples I quoted. In all the examples, you have seen that elastic property of the medium is used in transferring energy. Two examples are given here. Sound wave is an example. Water wave are occurring due to the elastic property of the respective medium. Okay, because air is highly elastic. Okay, air can act as a cushion. If you fill in some suitable enclosure, air will act like a cushion. So because of the elastic property of the air. Similarly, water is also having elastic property. And you can see that because of this elastic property, solid, liquid, gas, etc. act as elastic medium, and waves can be propagated. And such waves are also known as mechanical waves. Okay, mechanical waves essentially happens in elastic material because of the elastic property. So you can either title them as elastic waves or as mechanical waves. Okay, both are equally good. And second category is called inelastic waves, are also known as electromagnetic waves. Okay, electromagnetic waves. The propagation of electromagnetic waves does not require any medium. Okay, they can even propagate through free space. So we say that such waves hardly needs in presence of any medium. Okay, they don't need the presence of any medium. Okay, example is electromagnetic waves. And how they are produced? Actually, they are produced by the oscillation of charged particles. Essentially, for example, in an antenna, when some signal is produced, electrons are oscillating along the antenna. Okay, the oscillation of electrons results in the production of some field quantities. That field quantities are called electric field and magnetic field. It is shown here. So electric field oscillation produces magnetic field, and magnetic field oscillation subsequently produce electric field. So this alternative production of electric field and magnetic field enable the transfer of energy from one place to another. Okay, so that is how electromagnetic wave propagate from one place to another. So we collectively call them electromagnetic waves. Okay, in addition to this, there is a third category known as matter waves that it does not come under the purview of your syllabus. So I am not discussing it, but keep in mind that there is a third category wave that is called matter waves. So in general, waves can be classified into elastic waves or mechanical waves. Second one is electromagnetic waves or inelastic waves, and third category is called matter waves. Matter waves are essentially associated with electron propagation or proton propagation, applicable for elementary particles. When they propagate in space, some wave is associated with them. Okay, that wave is actually called matter waves. You will study in detail about the matter waves in higher classes. Okay? So anyway, in our current discussion, we need essentially mechanical waves and electromagnetic waves. Okay, matter wave we will not include in our discussion for the time being. Okay, so as I told you, there are transverse waves and longitudinal waves. And in transverse waves, we said that vibrations of the particles of the medium takes place perpendicular to the direction of propagation. Okay, that is the reason why they are called transverse. And examples are water wave is an example for transverse wave, because water molecules move up and down, but energy move perpendicular to that motion. A second example is electromagnetic wave, where also what happens, electric and magnetic field oscillate up and down, whereas energy propagate parallel to that, perpendicular to that. Suppose here electric field is oscillating up and down, energy will be moving in the positive x direction. Similarly, longitudinal wave, if the vibrations of the particles of the medium are parallel to the direction of propagation of wave, such waves are called longitudinal waves. We have examples: sound waves, Okay, one is example is spring waves in a stretched scene is another example. Okay, that is shown here. Okay, in longitudinal propagation, particles are oscillating to backward and back and forth. Okay, back and forth. So what happens due to that vibration, medium get compressed. Okay, compressed. This compression is shown here with the denser regions. There's a region of compression, and you can also see the certain region with low pressure. That's called a rarefaction. Okay, so longitudinal waves are essentially propagated by the generation of compression and rarefaction. We will look into more details in the coming slides. Okay. In transverse motion, I have already told that particles are oscillating up and down. They are actually not making any positive displacement in the horizontal direction. You can see from these graphics. Okay, anything you can focus on any particles. For example, you focus this particle adjacent to the yellow arrow line. You can see that particles are simply moving up and down. Okay, they are not making any horizontal displacement. Or for that matter, you can take any arrow, any green, yellow, orange, any arrow, and focus on the resulting particles. You can see that the particles are simply, even though you have an illusion that particles are moving forward, but if you make a close watch, you can see that particles are simply moving up and down. Particles are simply moving up and down. So that shows that there is no real displacement of the particle from their mean position, but energy gets propagated. That is the peculiarity of transverse waves. Okay, and it is beautifully illustrated here with the graphics. You can see that every particle of the medium is, suppose there is a continuous wave, then every particle of the medium is making a simple harmonic motion. Every constant particle, simple harmonic motion, right? Each and every particle, and that is symbolically shown with a spring and a mass. This alternative simple harmonic motion of each and every particle enable the medium to transfer the energy from one place to another place. Okay, so we can say that any wave motion is a combined action, a collective action of innumerable number of simple harmonic oscillators. Okay, innumerable number of simple harmonic oscillators collectively, harmoniously act together to transfer the energy from one place to another place. In such a case, waves are actually called plane progressive harmonic wave. Okay, such waves are called plane progressive harmonic wave. So this way, mechanically, we can illustrate any waves. Okay, which show what is the real mechanism involved in the propagation of such waves. Okay, and as I already told you, in longitudinal motion, we have compression and rarefaction. Okay, and this compression and rarefaction are beautifully illustrated here, both in the spring as well as in the air column. The second one is an air column, which shows how the longitudinal wave really propagate through the medium by the production of compression and rarefaction. And we will look into the little bit more detail about these longitudinal waves. As I told you already, they are propagating by the production of compression and rarefaction. So in some regions, what happens? Medium get compressed. Okay, dark regions are compressed regions, and the less dark regions are actually regions of rarefaction. And in compressed region, particles of the medium come closer than normal. Okay, their interparticle distance is less, whereas in rarefied regions, particles of the medium reaches farther than normal. Okay, their interparticular distance will be larger than normal value. That is how they are characterized. That is how we can differentiate between compressed region and rarefied region. But both compression and rarefaction is required for the real propagation of energy, for example sound energy, from one place to another place. Okay, And as I introduced, we are mainly essentially concerned with plane progressive wave. It's an ideal wave. Okay, for a plane progressive wave, in fact, its amplitude is constant throughout its propagation. Its frequency is constant, wavelength is constant, uh, and that is the ideal wave. Okay, in subsequent modules, we'll be essentially dealing with plane progressive wave, and in plane progressive wave, we will look into what is plane means and what is progressive means, and we have a third word called harmonic. So we will look into each and every term. What does it mean, and what are the important properties of such plane progressive wave, and how can we mathematically represent a plane progressive wave? Okay, with a clear illustration of all the notation involved in it. And of course, these plane progressive wave manifest so many phenomena. We will take one by one phenomena and analyze it both physically and mathematically. Okay, so that is the mathematical description of such phenomena is involved. All are highly interesting phenomena, and we are expected to be very thorough with each and every phenomena, because such phenomena will be later on used in different other physical situations. That is the very importance of studying those phenomena. Okay, and we also try to apply those phenomena for interpreting many other physical events. Okay, by proper understanding of these wave phenomena, we can use such knowledge to understand many other physical events in nature. Okay, that's the very use of this very understanding of wave phenomena. Okay, so with this we are concluding our introductory talk on wave, and here is a simple question for your assignment purpose. Classify the following waves into longitudinal and transverse wave. You will be given with a set of phenomena or examples or physical examples. Your duty to separate them into longitudinal waves and transverse waves. Okay, so think thoroughly about each example. Only then you have to understand it. Only then you have to answer it. Make them into a table and put them into appropriate tables. Okay, table with the two columns you can make, one with the longitudinal, one with the transverse, and put these examples. Okay, put these examples or events or whatever you can call them into the respective table, the columns, compile them in a single A4 sheet and submit in the assignment section. Okay, so it's a very interesting assignment. Suppose you don't know a particular example given here, you search it somewhere in books, library, or in any internet site, find out this answer and properly set in the table. Okay, so this is what I want to say. I hope you understood the ideas clearly. You enjoyed the introductory session. So see you next time. Thank you all of you.